Okay, now I'll start. Probability. Probability is a non-negative number assigned to each event in a sample space S. Okay. Let A is an event in sample space S. Then the probability of event A, probability of event A is denoted by P of A. Okay. So probability of event A is denoted by P of A. Then how to define the probability? The probability of an event A called P of A is defined as, okay, P of A is defined as, see the simple definition, NA by N. What is NA? Number of favorable outcomes by total number of possible outcomes. Okay, I'll explain this. What is this? Ratio of number of favorable outcomes of the event A divided by total number of possible outcomes in the sample space S. Okay, we considered first the sample space S. Sample space S consists of all possible outcomes. Take an event A in sample space. Now the probability of the event A, which is P of A, is defined as number of favorable outcomes of the event A divided by total number of possible outcomes present in the sample space S. Okay, I'll explain you by taking a simple example. Tossing a coin. Okay. What are the possible outcomes? Head and tail. So your S consists of two possible outcomes, head and tail. How many number of possible outcomes? 2. Suppose, take your favorable outcome as getting head. So how many favorable outcomes are there in the possible outcomes? Getting head is the favorable outcome, so only one. Okay, so if getting head you consider as the event A, then what is P of A? How many number of favorable outcomes? 1 divided by, what are the total number of possible outcomes? 2. Okay, so P of A is equal to 1 by 2. As this is getting head, I can write it as P of H. Means probability of getting head is 1 by 2. Similarly, probability of getting tail is also 1 by 2. So this is probability. Suppose take another example, throwing a die. How many number of possible outcomes are there in throwing a die? 6 possible outcomes. So suppose take your favorable outcome as getting the number 2. Then what about your probability? Favorable outcomes of Only 1, because 2 is 1 only. And what about the possible outcomes? 6. So totally, what is your probability of getting 2? P of 2 is 1 by 6. Same way, in throwing a die, probability of getting 3 is 1 by 6. Probability of getting 5 is 1 by 6. All the events probabilities are 1 by 6. Okay, so that is the definition of probability. Then, we'll see axioms of probability. Axioms of probability. What is the meaning of axiom? Axiom means truth. Okay? Then, for probability, the first truth is, axiom 1 is, P of A is always greater than 0, greater than or equal to 0. Means, never probability is a negative number. So, probability is, I already defined, probability is a non-negative number. That is axiom 1. Then, okay, I'll write here. That is non-negative. It represents non-negative nature. Then, axiom 2. Axiom 2 is P of S is 1. What is actually S? What is actually S? S is sample space. We know it. And the sample space is universal set. Sample space is universal set. Means your S is a certain event or sure event. Therefore, always the probability is 1. Okay? S is sample space, which is called universal set, and we know the universal set consists of all possible outcomes of an experiment. So, it is a certain event or sure event. So, probability of that sure event is always 1. Then under axiom 2, we have another point, P of 5 is equal to 0. What is actually 5? We know it represents null. So, the probability of null event or impossible event is always 0. I already explained null is an example for impossible event. So, the probability for null event or impossible event is always 0. Then, what is axiom 3? Axiom 3. Suppose, take a sample space S, which consists of n events. Those n events are represented by an, where n is 1, 2, etc. n. This capital N may be infinite. And if all these ans are mutually exclusive, that is, am intersection an is always 5. What are mutually exclusive events? No common elements. If there are no common elements, what is their intersection? Their intersection gives you null value. Okay, so mutually exclusive here means am intersection an is equal to 5 for all m not equal to n. Then P of union n is from 1 to n, an is equal to sigma n is from 1 to n, P of an. This is axiom 3. Means probability of unions of all the events is equal to summation of the probabilities of individual events. In a better way, you can write like this. P of A1 union A2 union P of A1 union A2 union A3 etc. AN is equal to P of A1 plus P of A2 plus P of A3 etc. P of AN. Okay. So axiom 1 is regarding the non-negativeness. Axiom 2 is regarding the sample space and null set. And axiom 3 is yes, probability of unions of all the events is equal to the sum of probabilities of individual events. Okay. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.